Code quality plays an important role in developing solid software. One of the most effective ways to ensure the healthy state of the code is test-driven development. Test-driven development is a programming approach in which developers write production code in response to a test case, as opposed to the traditional process where code is written first and relevant test cases are created later. In this session, you'll get all the technicalities of test-driven development programming approach. But before we begin our session, do not forget to hit the subscribe button and click the bell icon. So let's discuss our agenda for today's session. First, we are going to discuss about what is test-driven development. Then we are going to discuss about what is unit testing. Then we are going to learn about why the unit testing we are doing. Later on, we are going to discuss about its pros and cons. Then we are going to learn about what is NUnit. Later on, we are going to discuss what does NUnit framework provides. Then we are going to learn about installation and setup of NUnit. Later on, we are going to discuss about preparing an NUnit test class. Then we are going to discuss about writing an NUnit test. Moving ahead, we are going to discuss about some of the basic rules for placing and naming tests. Then we are going to learn about attributes. Then at the end of the session, we are going to learn about what is assertions.
Okay, so I'll come down to the topic. Actually, what we have is nothing but it is on unit testing. Okay, so this is a very crucial topic into development. So whenever we do development, right, we do C# development, or we can do any type of development. It could be a plain Windows development, it could be a web development, it could be a cloud development, anything. Okay, so we have to do unit testing. Okay, so this is a topic. What we have is test driven development using NUnit. So don't get confused with the word test driven development. This also comes under unit testing. So basically we'll be learning the unit testing, which is again the more generic word about test driven development. Okay, so in this we'll be learning unit testing. Whatever is there in unit testing, that we'll be covering. Okay, so let me start with this topics there. So let's start the things there. So basically what we'll do is we will do, this is a small agenda I'm just sharing there. So this is a test driven development. We will understand what is test driven development. And then of course, we'll start with the topic unit testing. What is unit testing? Why we need unit testing? What are the pros and cons of unit testing? And then again, we'll start with NUnit. Then I'll come to know, I'll let you know that what is NUnit. And then we'll see what is the framework and how you will do the installations. So I'll show you how to do installation and setup of NUnit, and then again we'll start writing the NUnit. So first, before we write the NUnit test cases, I have to show that we have to prepare for that. Okay, what is that preparation? And then finally we'll start writing NUnit and the basic rules of writing the unit tests. And then of course we have attributes and assertions, which are again related to your NUnit framework. Apart from that, I haven't listed out over here some of the topics which I will be covering, especially the mocking frameworks, MOQ. Okay, so that part also will be covering here in this 3 days. Okay, so let's start with the first topic. Okay, so we'll start with test-driven development. What is test-driven development? So basically, what I will do is that, so what this test-driven development is, see, we do development, correct? Now, if suppose, for example, if a task is given to you, a development task is given to you, what you generally do? For example, you've been told to, suppose, for example, create a model of an, something like an shopping mall. Okay, or I can say instead of going for shopping mall for a big one, I'll say that okay, you have been told to create an, and software like a POS. POS is something in point of scale. Generally, you go to shopping malls and then you purchase. When you purchase and when you pay the bill, right, at the counter, those are nothing but the POS machines, right? So, for example, you've been told to create a software for the like a POS. Okay, or in this POS, right, what you want is the name of you need customer details. Okay, when you're generating a bill for a customer, right, what information you need on the bill? You need the customer details, you need the order details, correct? These two things are there. Now, for example, if the same thing has been told, okay, instead of going for a very lengthy one, let's concentrate on creating a customer class or creating an order class. So what generally you will do? Yeah, now for example, you got the requirement, you also got to know that what different attributes, what different properties you will be writing in both the classes. Okay, you got the information. You also know that what methods you'll be writing in both the classes. You have this information. What is the next? So when you write the code, right, what you do generally, you just go and write the code? No, you should not, right? As you said earlier, right, you will first of all gather the requirement. Okay, gathering is one part. You gather the requirement, you have to understand not only the requirement, but all possible scenarios, right? What possible scenarios are there? Those possible scenarios you have to understand. Means when I say scenarios are nothing but the test scenarios. Means for example, when you say order class, right? When you're creating an order class, what different test scenarios will be there? So I'm not saying that you are thinking on a QA line, the test is what you do. And I believe you all are developers, right? Or is it a mixed crowd? So, so when I say testing there, of course, even developers are also responsible for understanding the test scenarios. Of course, you will not create those test scenarios. The test scenarios are being created by the QA team, the quality assurance team, or the testing team. The testers will write the test cases, and then based on this test cases, they will test your code. So as a developer, okay, you are also involved into testing, but the testing what you do is a unit testing, right? And for writing a unit test, right, what is important to understand is test scenarios. What different test scenarios this particular your code has. So for example, when you are writing an order class, okay, what different test scenarios are there? For example, they will test what is the name of the product. So whether the name of the product is having the correct description about that product. Again, they will also test that what is the price of that product. They will also test in the order what is the quantity of that product, right? Likewise, lot many things they will do testing. So you should be, these are nothing but the test scenarios or test cases, I will say rather. Test scenarios is a bigger word, right? So when you write one test scenarios, right? So for one test scenarios, a tester writes multiple test cases. Okay. Scenario is something, for example, if I say that generate a bill is a scenario, a test scenario. When you generate a bill, of course, you need multiple test cases to be understood, right? For example, the name of the customer should be there, right? The contact number of customer should be there, right? Then in the order, you should be having the product list. Likewise, there are some certain rules, right? As per the requirement, whatever the requirement is saying, okay, these are the criterias, right? These many criteria should be there. Only then you generate a bill, right? So different test cases will be there. For example, one test case will be there to check the name of the customer and the details of the customer, right? The other test case will be there to check the details of your product, the item, right? And the other will be there to check whether the final total of the bill is coming correct or not, right? So likewise, there will be different test cases under one test scenario. So now coming to the point here, so one test scenario will have multiple test cases in it. And when you are writing a unit test, right, what is your job? Your job is to understand these test cases, right? And you will write a unit test for these test cases. Okay. But before we do all these things, right, now, when you know the test cases, right, when you know the test scenarios, okay, for the code which you are going to write, right, for example, the order class, right? So before you jump down to directly creating an order class, what is recommended? Now I'm coming back to my test driven development. I'm coming back to test driven development concept now. what test driven development says that don't jump directly in writing the code. Okay, so don't create the order class first. Rather, you create the test cases first. I mean to say, you will first start writing the unit test first, even before the code is there. Okay, even before you have created the class order, you should create a unit test for class order. So what will happen in this case when you will write a unit test? See, when you say unit test, means you will write a test method, right, for your code. See, generally when you say unit testing, right, unit testing you are always doing on a method, not exactly a method I will say rather, but to be at least for now, to make it simple, I'm saying that keep the scope of writing unit test for a method. Okay, so for example, if your order class has different methods, generate bill, get customer details, right, right, get product price, right, all these are different methods in your order class, correct? So for each method you will be writing a unit test. There could be, of course there is a possibility for that, for one test, for one method, for example the generate bill, you will be writing multiple unit tests. Okay, this is there, I'll show that how it is possible. Okay, so when you when you say that, right, before you write the code, now there is no class order, and I'm saying that okay, you are you are writing a test method, for generate bill method. Now there is no generate bill method, correct? When I'm saying that there is no order class itself, then of course there is no possibility of having generate bill method also in that class, correct? So without writing this code, first of all I'll be writing the unit test. So in the unit test, what I do, I know the test cases, right, related to this generate bill. Okay, so I'll pick one of the test case, and for that test case I will write a unit test method for generate bill. Okay, and when I'm writing a test method, right, for generate bill, so what happens when I will run this unit test, right, whether this unit test will run or not. Okay, so what I see now, so definitely the code will work or not, it will not work. Why? Because there is no code, correct? There is no code, so it will not work. Means what? Now my first step, if you see on the screen now, okay, so when I say the first step is what, in TDD, in test driven development, what this particular approach, this is an approach for writing unit tests. So test driven development is an approach. Again, I'm saying test driven development is an approach, okay, a methodology using which I write a unit test. Got it? So what this approach says that write the unit test first and make that unit test fail. Of course, it will fail. Why? Because there is no code. You can see, make it fail. The first step is that make it fail. No code without a failing test. Of course. So when you say make it fail, of course, there is no code, so it will fail. Then what you will do? You will make this failure, right? The test method, what you have written here, you will make it succeed. So how you will make it succeed? By writing the code, correct? So now what you will do, you start creating a class order now. And in the class order, you will also add generate bill method. And in the generate bill method, you will write some code in it, some code in it, so that your test case, what you are writing right now, will succeed. So the first case is that you simply write an order class, add a simple generate bill method. So what happens? Then the second step will happen. And when you run your test method now, it will work. Why? Because that test method has seen that there is a generate bill method and an order class. Both are there. So of course, so what will happen? The second step, it will work, right? But this is a simple one, right? This is a simple one. Still, it doesn't have all those test cases scenarios, right? So for example, You will write a simple unit test case first, a test method first, and then you will improve it. In the next step, what you will do, make it better, right? Make it better means what? You will refactor the things. For example, this refactoring is onto your code level, right? What you will do, you will go to your order class, you will open your generate build method, and again you will write some more code to improve it. When you're writing more code, it could be a possibility that you have to refactor your code. For example, when you're writing your generate build method, capturing all the test cases, right? So your generate build method may get lengthy, right? May get lengthy. So what you will do, then you will try to reduce the size of your build. What is the best practice of writing a test method? Means, for example, what is the um, uh, allowable length of a test method of a method in C sharp, right? When you write a method, there are some certain best practices what Microsoft has suggested. So it has given the length of an good method. So if those many lines of code is going extending towards further, then what it suggests that you have to break that method into multiple methods. Okay, so what is that allowable length of how many lines of code you can write in a method, in a C sharp method? So you can write 20 lines of code in a method. If it is exceeding more than 20 lines, it is always suggested that you should refactor your method, break your method into multiple methods. So 20 lines, it could be 50 lines, it could be 100 lines, right? But 100 lines is not a good practice. So 20 lines is a better one, right? But in some cases, people also go and write 50 lines of code. So it depends on how you manage your code, how you are able to manage your code. Not only you, I'm saying the whole development team, your test leads. For example, you are a software engineer or senior software engineer, right? You have a lead over there, technical leads, right? So as per the requirement, right? So the technical leads will suggest you that what should be the length of your test methods, not test methods, length of your methods, C sharp methods. Okay. But as per the best practice, it should be 20 lines of code. 20 lines of code you should be writing under one method. And when you say that, when you're making it better, and of course, you see that your method is going beyond 20 lines, then you need to refactor. So that is what it says, that make it better means it is refactoring. So refactoring doesn't means always, breaking your method, lengthy methods into smaller ones. No, it is not always that. Sometimes you may have to change the signature of your method, the number of parameters you have, right? That is also comes under refactoring. Getting it? Lot of things are there in refactoring. I believe you know the word refactoring, right? You have done refactoring earlier, correct? So instead of doing refactoring at a very later stage, what we generally do in a conventional development, not in test driven development, what we do in our conventional development, we write the code first. We'll make those code lengthy and all, right? And then what we'll do, we don't even know whether the code what we have written, whether it is testable or not. We don't even know. And then when you start, after you finish your code development, then the next step what you do, you start writing unit tests for that. And when you write unit test, you will come to know, oh, I cannot write a unit test method for this particular method. Then what you do you go back and do a reverse engineering. You will refactor your code so that it becomes testable. So this is something, this is something a lengthy time, right? You have written the code, then when you are writing the unit test, at that time you came to know that you need to refactor. So instead of waiting for a long time, what is suggested in testing, in test driven development, that you don't write the code first, you write the unit test first, make it fail, and then pass it, make it success by writing the code. So in this particular approach, you are very much sure that you are writing a testable code. First point. The second advantage of this method is that, okay, you are very much sure that you have covered all your test cases, right? Many times you have seen, right? You have written a code, right? You have written some classes and all, and you found that, oh, I have missed some scenarios. I have missed some test cases in it. Getting it? I have missed some conditions. I'll say rather in this way. I think the better word, what you understand right now is condition, right? Oh, I missed to write this condition. Correct? This happens, right? Or a condition what I written is not perfectly, it is not correct, right? I need to do some changes in my conditions. What I have written the if conditions, correct? And this happens. This happens not only with you, it happens with all. Okay. So to break this cycle, okay, to make the things more effective, test driven development approach is suggested. Now you got what is test driven development. So when you see the diagram here, what you do, first of all, you add a test, then run the test, and then change a little code. Okay. So when you run the test, okay, if they work, you will add another test. And if when you run the test case, if it is not working, then what you do, you go to the bottom step here. So from here, from the run test, you will go. If it is failed, you will go and change the code. You will change the code so that your test case should pass. And you will repeat the steps from run the test and change the code little. This we will keep on doing until your test case is, until your test method is not success. Until your test case doesn't work, you have to repeat the second and third step, second and third step. You will keep on doing it, keep on doing it. Run the test case, change the code. Run the test case, change the code. And when it works, you will you have finished writing that test method. Then you will go to the next test method, adding a new test method again.
Yes.
Do anyone have any query on this? I believe that we all had taken a very good breakfast, right? Okay, so I think this is very much clear what is test driven development. And I'll also suggest and recommend that you always whatever you understand, right? Whatever you understood, right? Keep a note of all these things. So definitely, as what we do in the colleges, right? We prepare notes. So again, I will say that even though still you are a college, you are a student, even I am also a student, right? So for a student, the best practice is that whatever we are learning, we prepare the notes for it. So I'll suggest the same thing. You prepare the notes for this. Whatever the important things you feel you have understood for this particular topic, please keep on noting it. You can keep this note on your notepad, or you can also keep on the notepad which you have in your laptops. Okay, anywhere, digital or non-digital, whichever you feel comfortable, you can. But I will recommend the digital form. Okay, so moving to the next. So what exactly test-driven development will do? Of course, it will improve the quality. Of course, it will aid the programmers and customers to ambiguous requirement. Of course, so when you are writing the test methods, right, you are understanding the requirement in complete sense, right? Means you understand all conditions of your code. Then the next thing is that the code is testable. The very big feature of this test-driven development is that you always write a code which is testable. Okay, so when you say code is testable now, so when you say code is testable, it means that, for example, you have written a method, right? A generate bill method, okay? And it doesn't have any parameters. For example, it requires a parameter of, a parameter which says that, to generate the bill. For example, you may require a parameter like a flag, you know, a flag. For example, this generate bill you have written for both, for the vendor, for the supplier, as well as for the customers. Then what you will do? And you want that, okay, with a particular flag, right? When you say that I want to generate the bill for the supplier, for the vendor, it should generate the bill for supplier. And when I say the flag as customer, it should generate the bill for customer, right? So your generate bill should have one parameter, correct? And you haven't given the parameter. Okay, what you're doing internally, you have written the code. What will happen? Can you test the code? No. See, the flag is coming not as a parameter of method, but it is coming as a property class. Getting it? So what you have done actually, you have written the flag on the class level as a property. Okay, the property is being set, right? But it is not a not a parameter of this generate build method. Getting it? So the code will work, but it is not testable. When I am writing a code for generate build, there is no parameter. So I cannot write a test method for this because this particular test method, this particular generate build method is dependent on my flag value, right? My flag, which is again a separate property. Again, separate property means again property is also a method, correct? So I will be writing one more test method for that property also. So in short, these are two different methods, right? This is one example. Another example could be that when I'm generating a bill, right? I need to have instances of what? Customer and product, both. If I don't have the instance of customer and the products, I cannot create the order, right? And what I'm doing when I'm creating the instance of this customer and the product, I'm creating the instance inside my generate method. This mistake we generally do, right? Inside the method, I'll create the instance. And when you do this thing, right, and you are writing a unit test method for generate build, okay, you cannot pass the instance of the customer. Can you pass the instance of customer to generate build method? No, because there is no such provision given in your test method, in your generate build method. The signature of generate build is not allowing the user of the generate build method to pass the instance of customer and the product, right? So this is also a code which is not testable code, and we end up in writing code like this. Many scenarios you have seen. Now you can go back and check that yes, you have done this mistakes, not this mistake, mistakes like this, right? So this makes your code not testable. But when you write, when you are going with the approach test driven development, right, you are very much sure that whatever code you are writing, it is testable, because you are first writing a test method and then the code. So in this case, you are 100% sure that the code what you have written is testable code. So that is what it says, that testable code. Now the last point what we have here brings clarity about what test method the program should pass or fail. So yeah, you get the complete clarity. What are the test cases which will make your program fail or pass? Okay, program. I'm not saying the unit test. I'm saying your code. Okay, your code. You know that in which scenarios your code will work and in which scenarios your code will fail. So all this clarity you will get when you go with the test driven development. So I'll go to the next thing if no queries are there. So now I think we are clear. I'm not saying you have become master in test driven development approach, but you got what is the approach says about, correct? Now we'll come down to the topic unit testing. What is unit testing? So basically unit testing is a wider concept, and test driven development is an approach to write unit testing. Okay. Now unit testing, when you say what is unit testing, first of all, right? So what you understand, what is unit testing? Yes. What you feel, what is unit testing? So basically unit testing is what you know. So you do in unit testing, you test your code, correct? So when you test the code, you should know on what basis you will test the code, correct? You should know the conditions based on what you will test your code, correct? So that is what unit testing is about. So to test each condition, right? Each condition, each criteria of your code, okay, you will write a test method. That is nothing but unit testing. So I can say that now. You can see the definition here, what I given. Unit testing is a code that is written by developers for developers. Again, this is very important that you are writing the code not for testers. You are writing the code for you only. I mean to say you means developers only. So developers are writing the unit test, and they have written this unit test for whom? For developers only, not for testers. Testers, they do a different type of testing over there. Okay, they do the functional testing of your code. Okay, so they also do a testing, but they do testing not through unit test. They do testing through testing scripts. Okay, so this is actually a code which is written by developers for developers, and it exercises a small specific area of functionality. So you will not pick the whole functionality, rather you're picking one condition of that specific scenario, one condition of that functionality, not the whole functionality. The whole functionality is about generating a bill, but in generating a bill there are lot many conditions, okay, which need to be satisfied. Otherwise you cannot generate a bill. For example, until unless you don't have the product list in your order, you cannot generate a bill. Correct? This is one condition. Likewise, there are many such conditions. Then the next point what you have is, it proves this particular piece of code, the unit testing code, it proves that it is a piece of code does what is expected from you. Okay. So when you have written the code, right, you can give a guarantee that you can tell someone that, see, for example, you have written the code and you are giving this code to me for using the code, right? What I'll ask you, can you prove that your code works perfectly, right? So you should be able to answer this question. Means, for example, you have created some product and now you're selling this product to market, right? So of course the users, okay, want to understand, okay, that your product works perfect, your product works in different scenarios, right? For example, you have tested your code. For example, even instead of saying product, I'll rather say that when you purchase a car, right, so car is a product of some company, right? So when you purchase a car, right, you can see in the description they specify that this car works under these many different conditions, right? For example, it will work even though the temperature of weather is up to 50 degree, 40 degree, 60 degree. Like, well, I'm just giving an example, right? Your engine works. I'm not saying the car works, the engine works, right? The specifications of the engines are given, in which scenarios it works and in which scenarios it won't work. What are the good things, what are the bad things, everything they will list it out. And how they are possible to list it out? Because they have tested the code, they have tested their car in different condition. When they claim, right, what is the mileage of this car, okay, they have tested the mileage of the car, correct? Then only they are able to tell you that yes, this is what the mileage of your car is. Getting it? So the similarly, even when you are writing the code is also a product, right? Even though when you are writing classes, that is a product of given by you. So whenever you are giving this code to the testers, you have to prove to the testers saying that yes, you should be confident about your code, right? Yes, I have tested my own code in this for this particular test cases. So I'm very much sure that yes, my code will work in this conditions.
Just a quick info, guys. If you wish to learn testing and make a career in it, then we have a good news for you. Intellipaat provides Test Architect Master course in collaboration with IBM and Microsoft. The course link of which is given in the description below. Now, let's continue with the session.
Right? So that is what it gives a proof that it works as expected. The code works as expected. That is what the last point is saying. It proves that a piece of code does what is expected from it. So for example, when you will start the car by, turning the keys on, so your car should start, right? When you're applying the brakes, the brake accelerator you are pressing, right? The brake should be applied. Getting it? So that is what expected from the brake, right? So you should be thoroughly knowing that you are expecting when you're applying brake, the car should stop. So for that, you need to write the test cases now. Okay, this is what the unit testing do for you. So it means that when you're not writing a unit test, which which in most of the things are not most of the things. This is something and scenario what I've seen earlier, but nowadays everyone is very much cautious about writing. They understood the importance of writing unit test. Okay, so when you're not writing a unit test for your code, it means that you have created a product, means you have created the car. Okay, you haven't tested your car and you are selling the car. What confidence you'll have in selling the car? If someone asks you what is the mileage of car, you cannot answer. Okay, what is the life of this car? Every car has a life, right? They says that, for example, you are going for a hatchback, the small cars, right? They say that the life of the engine is guaranteed by the company itself, right? 1 lakh kilometers. After 1 lakh, it could happen anything, right? How they know that exactly 1 lakh, by this 1 lakh, okay, the engine will work, correct? Because they have tested. So someone asks you what is the life of the car, right? When you're selling a new car and you haven't tested your car, you cannot answer. So no one will purchase the car. And even though they have purchased the car somehow, right? You don't know whether your car works perfectly or not, correct? So this is what the importance of writing unit test. Okay, so this is what the unit test is. Unit testing is, we'll see what we do in unit test. We write method, class, or application, write unit test, run unit test, and then we fix the bug. Okay, this happens in the unit test, right? Right, first we write the code, then we write the unit test. If time is there, then we run the test. If time is there, then we fix the bug. Generally, people who skip the unit test method, what happens? They write the code and they directly give it to the testers to find the bugs, right? Okay, so this is generally what we do is, write the code and then we give it the code for the testers to test it, and then they will find the very primary and basic bugs, right? Then there will be huge list of bugs raised on your code. So to reduce all these bugs, you have to write effective unit test method, effective unit testing. Clear? Okay. So now what is the process of writing unit test, right? First we do write unit test, right? Then write test actually we say, right? Then we'll run all the test, what you have written. Okay. Then make test pass by writing production code. Okay. Then again you will run the tests. Okay. Then what you do, if any bugs are there, you will fix the bugs. If your test case fails, right? If your test case fails, then you will fix the bug. And what we'll do, again you will go back and again run the test, and you will check whether your test case fails or not, runs or not, right? If it is there, right? When you run the test things, if all the test case pass, no need to do anything. You're happy. Okay. Second thing, refactor production code if test passes. So even though your test cases are passing, okay, you should not be completely happy. Okay. You should be always thinking, can I refactor the code? Refactoring is something, which says that make your code more effective. Effective means not only in look wise, in performance wise. Okay. In performance wise, it should be good and better. It should also be good in many other factors. For example, the code should have readability. The code should not be too lengthy to understand. Okay, all those, the rules. If it is satisfying, your code is satisfying, then no need to refactor. But if you see that the performance is not there, right, because you're not written the the optimized code, I'll say optimized code. Okay, so then of course the performance will not be there. So to write the optimized code, you need to refactor your code, and that's what we do, okay, in refactoring. Okay, so you run all the test cases. If it is pass, and you see that no refactoring is required, then you can say that yes, I finished my job of writing unit test, right? But if you see that the test cases has passed, but a refactoring is required, then do refactoring, right? But if the test case has failed, not even passing the first primary condition, right? If it is failing, then you need to fix the bug and you need to run the test case again. And then again, you have to check whether it is passing or not, whether refactoring required or not, and then going forward. So this cycle will keep on going. And once this particular test cases are passed and you see that no refactoring required, then you moved on to write another test case, right? Then you write the next test case. But when you write the test case, make sure that you should not only run that only one test case. Huh? Okay. For example, you started writing the unit tests, correct? For the first unit test method, it's fine. You will run the test case. If it is success, okay, you will finish this test case and again you will write another test case, another test method. Okay, you have written the another test method now, and you will run this test method. Okay, when you are running this test method, don't run only this newly created test method. You have to run all the test methods. Means the test method what you have written earlier, even that also you should run, because sometimes when you are refactoring your code, right, you are changing the code, it happens that the previously written test methods get failed. It happens, mostly it happens. Okay, that's the reason. If you see here, even though you're writing a test method, right, one test method, it is suggesting that run all test, not single test, run all test, not single one. So that is what the process is saying about. Got it what I'm saying now? What is unit testing now here, and how it should be written? What are the different steps in it? Okay, so what is the advantage I'm getting with unit testing? I'm having the better code. I have given the better design. Of course, the design is good. The code is easier to maintain later. Of course, the code what I written is a maintainable code because I have refactored it, right? See, another reason why a refactoring is required. The first reason I told you earlier, right? For performance. And the second is readability. Now the third thing is that you also refactor your code to achieve maintainability. So you should write the code in such a way that it should be maintainable. Maintainable means if any changes comes tomorrow, for today it is fine, but in future some enhancement is there, right? And because of this enhancement, you need to modify some existing method. So you should be able to do it with minimal changes. With minimal changes, I'm not saying no changes, with minimal changes. That is called as maintainability. Getting it? So even you can achieve this thing, the code is easier to maintain. Next point is that confidence when you code. Of course, you have confidence with your code because you are testing the code. So of course, your confidence is there because someone asked that you return the generate build method, whether it works or not, whether it works accurately or not. So that is your confidence comes. Yes, it works. I know I have tested the code. See, this is what the test methods I've written. And I have seen the code works. So that confidence you will get. Okay, then the decrease the number of bugs. Of course, this is very, very important feature of unit testing. It decrease the number of bugs, which see these bugs will not escape, right? These bugs will come at a later point if you're not writing the code perfect, right? If you're not writing the code to its optimized form, okay, then what will happen? The bug will be there. And when the bug will be found, when you send this code to the testing team for testing, means you have written the code, you have done the building of the code, right? And then you are deploying this code in your development environment. And once it is deployed, after that, this particular code is given to the testers. Testers will again, will run the code from their testing environment, and at that time they will come to know, oh, there are bugs. So you can see the length of time you have missed out to find those bugs, which you could have found way earlier, right? Way back. So the bugs which you could have found at the beginning, you will be finding these bugs at a very later stage. So you have not utilized your timing, not only your timing, even the tester's timing also, because testers has wasted his time in testing your code, and finding the bug. When he find the bug, of course his work is to test the bugs only, but he found the bug. What he will do, he will raise the bug. So definitely for raising a bug also, he will be using some tool, right? A tool like Jira or something. I'll not mention the tool name rather. A tool like Jira is also there, because Jira is widely used. I'm using the word Jira. Okay. So what you will do then, the testers will raise a bug in the Jira, and then this particular bug will comes to you. So you can see the amount of time you have wasted, the amount of time the tester has wasted to raise and give back the bug to you. So this is not recommended. So to utilize your timing, you have to write a unit test much earlier than it has been, then the code is sent to the testers. So before you send the code to the testers, you should be writing that unit test method and test your code through. So now I think slowly you are coming to know that how much important unit testing is. Correct? Unit testing is very, very important. And of course, the last point, it will make your life easier. Of course, not only everyone's life becomes easier. Okay, so the pros, but again, there are some pros and cons of unit testing. Of course, for every concept, right, there is two sides of the coin, right? Every coin has two sides. So of course, pros and cons are there for unit testing also. Pros, we have seen the good part. We have seen that you will get the quality code. Okay, you will get the regressions error spotted very early in the stage. I'll just give a metrics there. When you write a unit test method, a perfect unit test methods you are written, okay, to its maximum, suppose, or to its optimized state, right? So it means that you have reduced 90% of your bugs, 90% of your bugs you have fixed in the development stage itself. So that is a huge improvement. That is what. So 90% of the bugs you get identified in the development stage itself. So that's the reason, unit testing is very, very important. So code quality is there, then much more testing will happen, then the unit, it will take minutes to test the code. It will not take much time, to run the test cases. How much time is required? When you return the unit test and run the test case, it will not take much time. Okay, but there are some certain cons also, the bad things also. Of course, when you write unit test, you need to spend some more time in writing the unit test, of course. So this is an extra work which comes on you. Of course, it will come, but the benefits are more than that. So an extra work of 20 to 50% work can double your development time. So when you are, estimating your timings, we listed it out, and we also estimate the time there, correct? We also provide the time, how much time is required to finish this particular task, correct? So when you are giving that estimation for that task to be finished, right, you should also add this extra work timing, right? You also need timing to write unit test. So you should add this timing also in the estimation, not only the timing for writing the code. Even when you are to write the unit test, you need some time. So add this time also in the estimation. Don't forget this. Generally, we forget. And then what happens? Then the rush comes at the last hour, because I haven't estimated the unit testing method, right? I haven't estimated a time for this, and I haven't given the time for this. So of course, that will be a rush, that will be an overburden and overload for you. Okay, and then what we decide then at the last, okay, let's keep writing unit test. We'll see it in the latest sprint. So we'll take this as a backlog, okay, and then we'll move further. So this doesn't happen. So this is not recommended. Of course, there will be an extra work, and you have to estimate the time accordingly. The second bad thing about unit testing is that rework of test is required. Of course, you need to change. You may have to modify the previously written test cases, the test methods, if the code, right, for which you have written the test cases or the test methods, okay, that test code, the code has modified because of enhancement. Yes, of course, you may have to change the code. When you change the code, there is a possibility that the test cases which are dependent on this on this code may have to modify. So this is also another extra things and additional overhead which comes as a technical debt. I can say this is a technical debt, okay, which comes as a technical debt on you. Okay? But fine, the benefits are much bigger than the cons. So of course, we have to live up to this, the bad things, because the good things are more. So we go. I'll move to the next topic now. Okay, demo. I'll show you the demo now. But before this, okay, okay. So before this, going to the practical demo and all, we have to create some background. Okay, I cannot directly, show you how to write unit test. Okay, we need to create some background. Only then we are able to do some practical hands-on. Still on, we are on the very early stage, very early stage. So let's finish this part there. So what is unit testing? So NUnit is something, again, a testing framework. So we have seen what is test-driven development and approach to write unit test, right? We have also seen what is unit testing, right? So when I want to write unit test now I understood unit testing as a concept, correct? And to implement this concept, what is the approach? I've seen test-driven approach. I should go with it. Okay. Now with these two things, still I cannot write a unit test, because to write a unit test, okay, you need to follow a framework. You need to follow a particular framework. Okay. So NUnit is one such framework. So there are many testing frameworks in market. For example, NUnit is one of them. What we are using it. So we will write the unit test as per the NUnit testing framework. So this particular testing framework has given some rules and policies, rules and regulations, right, to write the unit test in that particular format. So NUnit is such testing framework. Likewise, we also have other frameworks also. For example, before with NUnit, right, we also have MS test. MS test framework. Okay, so MS test framework is also there. You might have heard about XUnit, correct? XUnit, right? XUnit is one of the latest framework what we use with .NET Core. Getting it? But we will not be using the XUnit. Rather, we are using NUnit. So XUnit and MS test, okay, both are built-in features. Both are built-in frameworks inside your Visual Studio. Okay, but NUnit is a third party testing framework. So right now we will be learning unit testing through NUnit, not through MS test, not through XUnit. Okay, clear very much? Okay, so this is a framework which will help you to write or automate unit testing. Next thing is, it is free. Of course, you don't have to pay anything. It is open source, so it is free. So free is always recommended, right? So that's how people are using NUnit. because it is open source and free. Provides a class library. It will provide you a class library which will help you to write test scripts. Of course, when you write test methods, so those are nothing but also known as test scripts. Okay, so this test scripts, okay, when you are writing, you should be able to write it in a easier way, right? And this happens because NUnit testing framework is giving all these leverages to us. Okay, I'll show you what those leverages are there, what those features are there, right? So those features I will be soon discussing. Okay, it provides you a GUI application where using which you can write the unit test and you can run the unit test. You can see it is passing and failing. Okay, and again, it is most popular unit testing framework for .NET applications.
Just a quick info, guys. If you wish to learn testing and make a career in it, then we have a good news for you. Intellipaat provides Test Architect Master course in collaboration with IBM and Microsoft. The course link of which is given in the description below. Now, let's continue with the session.
So you got to know, right? What is NUnit testing framework? So don't get confused with unit testing. Unit testing is a concept which you can implement it using this testing framework, NUnit testing framework. Now, what this NUnit testing framework provides? It provides us some class libraries. Okay, from this class libraries, there are some methods which we can use it, like attributes and assert. All this comes under from class libraries. So you will get attributes, you will also get assert. So I think you are aware of attributes, right? These are nothing but C# attributes. In C# we have the concept of attributes, right? Even this testing framework also has given its own attributes. Okay, I'll show you what are these attributes. Okay, and then it also provide you some assert. Assert is required to check whether your test method is is passing or failing. To verify your test method, you need assert. You need different asserts. So using assert, you will check whether your test method is passing or failing. So in assert, what you do, you write some condition which you want to test. Okay, so that is what the asserts are there. So assert is also very important. Okay, then it also provides a GUI tool. What it do, it identifies the tests in your code, then run the test automatically. It runs the test automatically. You don't have to run. Means when you return the unit test, okay, it will identify where you have written the unit test, and then it will also run those test cases, test methods also, okay, automatically, and it will indicate whether they are failing or whether they have passed or failed. So this particular GUI tool is there, which is also known as test runner. So it has a test runner which will run the test, and that is in the GUI form. So this is what the GUI I was talking about. Okay, so this is what the GUI it will provide you. So if you see in the left hand side, this is a list of all the test methods, different test methods, and you can see some of them are green, some are green, some are red. Red means they fail to work, and then you will understand from here the failed test cases you need to fix them. So this is what the GUI tool will help you. So you can come to know how many tests ran, how many tests didn't run, how many tests failed, how many tests, which test got failed. Okay, this is what the information I will be getting from the GUI. The reason why the test case got failed. Yes, it will also provide you the reason of the failure. If you click on the failed test case, right, you will come to know the reason why it got failed. and it will help you in fixing it. Okay. Then the reason of the test failed. Then the assert message you wrote, even the assert in the assert statement. Okay. You can also write the messages. So you can also see the messages what you have done. And the last, the code location that failed, the location of the code where it has been failed. So all these things are given by NUnit framework. Okay, so that is the reason you understood now why we need a framework, a testing framework to write a unit test methods. Correct? So now here what we'll do the setup and all. See, there are multiple ways of doing the setup and installations. Okay, the first method what we have, what I am showing. Okay, this may not be required nowadays because we have other ways of doing it. I'll show you the other ways of doing it. Okay, but this is something where, you know, this is a basic and a very generic way of doing it, or I can say a very raw way of doing it. Okay, so they have their NUnit.org. Okay, go to this site and you can download the latest version of NUnit. So for example, if I go here in this NUnit, you can check. Let me show you this. Okay, so this is also a way that just I want to show what is the latest version of this NUnit. So this is a site from where I can go and I can download. Okay, so it's a freeware, right? It's an open source, so don't have to work for the license. You can see the license, under license, they say it is an MIT license. Okay, even in MIT license, there are some restrictions that you cannot use it for the professional use or the commercial use. Okay, so some conditions are given. So before you use on organization level, generally what I recommend, you know, go to the MIT license and check what license is there. Not for you right now, but for the persons who are into the senior level, right, who decides which tool has to be used. So what they do, they go to this MIT license and check what are the terms and conditions over there, and then they use it. But okay, for you, anyhow, the NUnit is there. So from this site, you can download. So if you can see, there is a button here, download button. You can click on download, you can download. But right now, don't do this way. Okay, don't do this way. There is other way of doing it. Okay, so I'm just showing you multiple ways of doing it. Okay, the installation is conventional. Next step. Okay, you can also install and then install. There are two exes which you will get. Okay, you have to install both the exes and all. So you'll get the GUI and all. Okay, but don't go in this way. This is something and very raw way of doing it. Okay, so I will not recommend to do this way. What I will say rather, okay, I'll show you what is recommended now. So go to your Visual Studio first of all. Okay, what we'll do now here, before we install NUnit and all, okay, what we'll do, we'll create some code also, right? So the very first thing, I believe you have started your Visual Studio 2017, all of you, and make sure that you all are in sync with me. So I am using Visual Studio 2017. You can see here from the help, I'll show you what I'm using here. Okay, you can see that I'm using Visual Studio Enterprise 2017, right? So I'm using 2017. You might be using professional or premium. Don't worry about the premium and professional version, but it should be 2017. That is important. Okay, now once you have started this Visual Studio, go to your file and projects. The same thing what we do, right? Nothing different. Now here, what you will be doing, first of all, you will create a class library here. From here, you know, there are a lot of things here, right? So go for, I think in 2017, lot of things are not there. Category wise, we cannot sort it out. But in 2019, we can sort it with the category wise. Okay, fine. So here we are more interested in the class library. This class library, okay? Make sure that the class library what you have selected is .NET Framework, not .NET Core. Whenever you select the class library, make sure that you are selecting .NET Framework, not standard, not core, nothing. Okay, .NET Framework. And then give a name to your class library here. So we'll create some code for that. I'll say there customer, okay, order, this is service. Okay, click on OK. So it is creating a project for customer order service. Okay, now go to the solutions. Okay, from the solution explorer, go to the solutions and we'll add one more project. Right click on the solutions and I can add another new projects. Now here also, right, I have different ways of doing it. I can go to the test method. You can see in the templates, right? Here in the install templates, right? You can see there is one option like test. And from this options now here in the right hand side, choose NUnit 3 unit test project. So I'll choose this one because I cannot choose this one because it is .NET Core. I cannot choose this one because this is MS Test. I was speaking some time back, right? MS Test framework is also there. Testing framework is also there. I don't want MS Test. Again, XUnit is also another testing framework. I don't want this also. We are into NUnit, but I cannot even take NUnit .NET Core. I want NUnit test project for framework. I cannot go for this thing because it is unit test project, right? But not NUnit. I want NUnit, right? So I have to go with this one. Okay. So right now you select this one. I'll show you with this way also. Okay. Let's see that we need to customize this one, but fine, no issues. Okay. So I'll go with this one. Give the name of this application as, see, we are creating two different projects. Okay. Now this project is for testing, unit testing. So always keep your unit testing projects separate. Create a separate project for unit testing. Don't mix up this thing with the existing code. Okay. Now give this name is customer order. I'll give service dot, I'll say test. Okay. Have you all given the same thing? See, whenever you're giving the name of your test projects, always use the name of the service, the name of the application for which you are creating the test project. Okay, dot test. This is a convention what we follow generally. It is not a mandatory, but this is what the convention we follow. So this is an an corporate standard, industry standard. Now see this particular what is a project. See, for example, now here when you have DLLs, right? See, generally what is the idea behind creating a separate project? See, we create projects for assembly. Assembly, right? Assembly is nothing but it could be a DLL or it could be an EXE or it could be anything.
Yes.
So for each assembly, we create a separate test project for it. We won't mix up. Because the idea behind why this is there, because whenever, you are marketing this, you will be using this, you are making this DLL class library usable to the globe, to the outside world. Okay. You should also give the unit test methods with it so that the persons can check whether they can, run the unit test and can, at least they should be satisfied with that. Right? So we are not actually, I'm not saying that we should be giving this in the production code, of course not, right? But it is always to be handy. I'm saying in the terms, see, tomorrow when you want to do some development, okay, just think that you are a software owner, then you will come to know why this psychology is there. When you are creating a software, right, and you will also enhance it because it is your own product. Tomorrow in future, you may have to enhance. Of course, you have to. I'll not say you may have to, you have to enhance it, right? So tomorrow in future, right, whenever you do enhancement, what you will do, you will first check whether your existing software is working as expected or not. How you will check it? What is the shortest method to check it? You will run all the unit test methods written for that software. And you will come to know, yes, it works perfectly for all the previously existing test scenarios. And that's the concept is coming, that you always keep bundle of your class library and its unit test into one bundle. That's the reason I recommend that always keep, assembly, one test for it for assembly. Okay, now customer order service dot test. Okay, I'm saying okay here. So you can see here, actually, basically what happened when I choose the unit test for it, right? By default, MS test framework is applied to it. Here, if you see, this is my test for it, right? Go to the references, you will see this testing framework is applied, right? Which we don't want. Okay, so don't do any changes right now. Okay, keep as it is. Okay, then what we'll do, I will go to my unit test project. Okay, not this one. I'm going to this test project, right click on this. Okay, and I will say manage NuGet packages. You can see by default, these two things has been added because of the template. Okay, we don't want this, but don't remove right away. Keep as it is. Go to the browse. So you can see it is installed. Go to the browse, click on here and say NUnit. You will see all the options, packages available for this. Okay, so from here, we'll select the first two. Okay, we cannot select multiple things. Okay, so what we'll do, first of all, we'll install the first one. Okay, make sure that you have the latest version 3.13 and I'll say install. Done. If it is successful, you will see the option turning to uninstall. It means installed. This is one way of identifying. The other way of identifying, you can see, and down arrow, right? Green arrow came. It means this is installed. This is not installed. You can see there is no down arrow, right? This is installed. You can see here also from here, it is installed. Second thing is that click on this NUnit 3 test adapter. Okay, we need this adapter to run the unit test. Okay, the first package, right? What it is giving, it is just giving us the class libraries, assertions, and attributes, but it will not give me the test runner. The test runner, I will get it from the second package. Got it? What I'm saying? So it is beta version. Okay, I'll not go with the beta version. I'll go with the stable version. See, this is always a point to remember, that always choose the stable versions. Don't go with the beta versions. Okay, pre-release or beta, alpha, anything is there. Okay, no pre-release should be used. I'll go with the stable, latest stable 3.17. Okay, and I will say install. I can also install these packages from my package console manager. Package manager console is also there, na PMC. Here at the down, you can see from here also I can write the command and I can install the packages. I believe you know how to install the packages, right? NuGet packages. Okay, after this has been done, go down to, now I'll go to the, I'll just close this one. Always keep a habit of closing unwanted things. Okay, unwanted tabs. Now here I came, right? Now what I have to do here, if you see in the test for it, right, in the same test for it, I have two references. One reference for NUnit, other one is for MS test. So what I will do here, I think you have this unit test, right, created earlier. Got it? By default one, this one. I'll just modify to show you that how to write. Okay, before this, first of all, I will be saying I have to change the using. Okay, now I want to use NUnit, right? So what I will do, I will say there NUnit dot framework, this one. Okay, the first one. Then the next thing is that to write a class, right? I have written the test class, right? So test class attribute will not work for NUnit. For NUnit, I have to say there test fixture. Okay, and here I will not use test method, rather I will say just test. So small changes are there based on the testing framework you use, but the meaning is same. So for example, when I say I have declared the class, right, and I want to declare this class as a test class. not a class like this. This is not my test class, correct? This is normal class, right? But how to convert a normal class into a test class? By adding this attribute on top of the class, test fixture. Similarly, when I write a method inside a class, this is all my test methods. So to declare this is normal method, right? But this normal method will become extraordinary, and this normal method will become a test method when you add this attribute as test. If you don't add the attribute, this will become a normal method, not a test method. So what do you mean by difference between normal test method, a normal method and a test method? These test methods are identified by the test runner. When you run the test runner, they identify, right, where all test methods are written. How this is possible? Because of this attribute and because of this attribute. So the test runner knows, okay, this is the class, test class, and these are the test methods in it. So it will run these test methods automatically. Got it what I'm saying? Why these attributes are important? So these are attributes. These are attributes. So for now, I will write some assert over there just to check whether I can run the test cases or not. Okay. So to verify, right, whether my test method fails or not, what statement I use? I use assert. I use assert. I just put something dot that, and I'm just putting some condition, okay, just to satisfy it. I know that 1:1 is always true. So whenever the assert condition, see whatever condition you are writing here, if it is true, then only your test method is pass. So I written some condition over there. Save the code, always keep habit of saving the code, even though saving happens automatically, but not always. Means automatically when it will happen? When you try to build the code, right? It will save the code and then it will build. But always keep habit of saving the code after 3 minutes or 5 minutes. Okay, so this is fine. One more part still we need to do is, yeah, we need to build this code. First we will build this. Okay, build the first one. Okay, I'm not building the test project. First I'm building the class library, the code which I want to test. So it is there, it is working, right? And then what I should do in my test project, under references, I'll add the reference. Okay, I'll add the reference of this project. So if I go to projects, this one, okay, I'll add the reference of this here. Okay, so you should see two things here. First of all, a reference to the code under test. Okay, we call this as CUT. Okay, in short, we call the code under test as CUT, code under test, the code which you want to test, that is CUT. Okay, so your code under test library and the unit test, these two things are there. Even though I remove these two things, will not affect me. Okay, now what we'll do, after adding the reference, we will build the whole solution. Let's build the whole solution now. So both the projects are running fine now, means they are built successfully. Now what is the next step now? I should run the test cases, right? Until unless I don't run the test cases, okay, I'll never come to know what's happening. So go to the test menu. In the menu bar, you have an option test. Okay. Now go to Windows, and there is a test explorer, correct? This one. Okay, test Windows, test explorer. Click on this. Wait for some time because it is identifying the tests throughout your solution. Okay, I'm saying throughout your solution, not project. I'm saying throughout your solution. If your solution has more than one test projects, it will find all the test projects. Why? Because it is finding on the solution level. Now you can see it is identified, right? He identified that there is a test method. It belongs to, see, this test method belongs to this class. This class belongs to this namespace and assembly. Got it? But still, I haven't run the test cases. Okay. The test explorer has only identified. That's the reason, all these are blue one. Okay. Blue ones are nothing but they have just identified, but they are not yet run. So to run, say run all. Now see, it is running means again it will build the project. It will always build the project. From here, the test explorer is there. If I make it here like this, I'll run again. You can see here. See, now it is running. You can see all should become green. If it is green means done. All are working fine. And you can see it took only 110 milliseconds to run the test cases. Okay. Okay. So now what we'll do now, if you see, I haven't written any code till now. Okay. So first I will write the code. What I will do, I will write the code. So let's go to the place where my actual code is there. This is my class, right? I'll go through Solution Explorer. I go to the class. I'll change the name of the class first. I'll change the name of the class. Okay. So what I will do here, I'll first create the class customer. Okay. Just say yes over there so that this name also should get converted into customer. And now I can write the code in this. So I will add some properties into it. Okay. Let me add some property. I'll say the customer ID, and this is a property. So of course I'll say get and set. I'll add one more property here, public customer name. I'll create one more property here, customer type, and I'll say customer type here. So this is an enum which I'll declare here. Okay, I'll declare an enum here. Make sure that I'm writing this above customer class. Don't write enum inside the class. Okay, it is not allowed. Enum, I'm saying customer type, and I'm saying there some type premium, and I will say that special customer. Okay, these two things are there. Now it is there, customer type. Okay, customer type, customer. Okay, so I will add one more class into it. I'm adding a class, and this will be my order class. Don't forget to make this class public. And here I'll be adding few more properties. I'm adding some few properties there just to make it, realistic. I'll say amount. Okay, so this is my order class. Okay, I'll create one more class now. Now this is my actually models. I can say that order, customer, these are my model things, right? Now I'll write a business class now. A business class where I'll write the logic. If suppose I want to give some discounts, right? Based on my customer type. So this is my business logic, correct? Now I'll write my business logic into another class. Let me add one more class. Now this class is, I'll call this as, I'm calling this as customer order service. Say add, make it public. Don't forget this important step of calling it as public. Otherwise, you cannot use these classes in the test project. If you forgot to make it public, you cannot use it into the test project. Now here, I'll write one method to give the discount. So what I want here, now two classes has to be there, right? To whom I should give the discount and on which order. So I need two parameters here. customer and order. Right now here I'll give the condition. I have to check what is the type of my customer. Correct. If my customer is of type, right? If my customer dot customer type is equal to premium. If it is my premium, what I should do? I should give him some 10% discount to it. So my amount, right? I need to check the amount should come as what? Order amount. I need to apply 10% discount, right? So how I should be doing it? So I'll be saying there. So I'll multiply this order dot amount, and what I should do here, this should be by 0.1, right? Correct. This will become 10%, right? Okay. So I'll do this thing. This will do. Okay, but still this formula is lengthy, right? Can we reduce this formula? Lengthy formula to short. This is actually the actual business formula. Okay. So I want to hear the same thing. Now this is for one type. What about the other customer? Again, same thing. Customer dot customer type. Okay, equal to customer type dot. It should be my special customer. And again here the order amount. I want to give 20% discount here now. So what I will do? Okay, so I have given 20% discount to my special customers and no discount to normal customers. Okay, so I don't have to write one more if condition, not required. So just save all files, Control Shift S, and then build this one. Okay, always check that the code what you added, the newly added code should work first. So it is building successfully, no errors. Now go back to our unit test projects here. Now I'll just modify the name of this unit test class one. Okay. Now I'll give a name to my. Now see, I'm writing this unit test for which class? For customer order service. Getting it? For this class, not for customer and order. See, generally we don't write unit test for models. Okay. Remember this, we don't write unit test for models. Model doesn't have a business logic, right? They have only properties. That's it. So you should have some logic over there in the class. Only then we write a unit test method for this. Okay. So I have my logic only in this class. Correct. So give the name of my class as customer order service.
Just a quick info, guys. If you wish to learn testing and make a career in it, then we have a good news for you. Intellipaat provides Test Architect Master course in collaboration with IBM and Microsoft. The course link of which is given in the description below. Now let's continue with the session.
Okay, and then tests, right? These are all tests, right? Don't forget to write the suffix test. This says that you can easily correlate, right? Okay, this is a test set of tests written for this particular class. That's the reason we follow these conventions. See, yes. So this name will also change. Okay. Now, yes, now I want to write the test method for my. Okay. Now, if you see, I want to write for this, right? So basically, as per the rule, okay, the thing is that we should write unit test. Okay, the test method I will say rather. Okay, you should be writing test method for every code path. I'll say code path. I will not even say condition. I'll say code path. For example, how many code paths are here? So when I execute this code, right, it can go here. If the condition is true, it will go here. Okay, after this, it will go here. Correct? This is one code path. Other one. This condition can also become true. Right? This will not become true, right? Then this line will execute if it is true. it will go this one, and it will go this. This is another code path. And there is also third one, which we won't see over here at all, but it is there. That is for the basic customer. There is no discount. So that code path is also there. Okay. So just to make an understanding, you can take this as, if you're not able to understand the code path, right? You should always write unit, the test methods for conditions. So some conditions are visible in the code, some conditions are not. For example, in our case, the third condition is, it is not visible. It is there, but it is not visible, correct? So you may not write the test case for that. So don't forget, we write it for actually the code path, right? So basic part is not there, but it's still there. Getting it? So we write the test methods for every code path. Now see, so how many conditions, how many test methods I should write for each code path? For example, for the premium one now. So we should always write 3. Okay, 3. 1 for positive, minimum 3. I'm saying minimum 3. Getting it? Or I can say minimum 2 is better word to say. The third one, it is always good to write, but people, they skip it, right? But in some cases it is required. Okay, so minimum 2 and maximum anything which is required. Okay, but minimum 2 has to be written. 1 for positive, 1 for negative. The third one is for exception. The code can throw exception, correct? So where is the test case for exception? We don't have, right? So we should always count exceptions also. In some places, it has been told that we should not write test cases for exception, but I won't, I won't agree with this. You should also write test cases for exceptions. Got it? So minimum, I'm saying, I'm not saying maximum. I'm saying minimum, these many test cases should be there for one code path. There could be more also. For example, more than 3 also it is possible. For example, in this code, right, I have written positive and negative, right? Positive and negative. But in some conditions, there is a range, right? The value is in the range. Getting it? For example, I can add third condition here. I can give discount to my basic customers if their order value, right? If their order value is more than 500 rupees or 1000 rupees. Got it? Or between 500 and 1000 or between 1000 to 5000. Getting it? Then this is the range, right? So writing one condition, one test case only for positive is doesn't make sense, right? I have to check for both the boundary conditions, right? Less as well as higher, the maximum and minimum, and in between. All these 3 will become my positive test cases, correct? And only then I can say that yes, I have tested my condition thoroughly. So in positive, I got 3. In negative, I could also go with 1, at least I should go, right? In which it fails, right? It could be, again, I could also write more than 1 negative test cases. For example, here in this case, right? I can write the negative test case for the premium by saying that if the customer type is, for example, how I write the negative test case for this premium? If it is basic, right? So then this will not come under, right? This is negative test case, right? I can also write negative test case by saying customer as null or order as null also, correct? Yes or no? That is also a negative test case, correct? If the customer instance is null or the order is null, that is also another negative test case, which will come for premium or special or anything. Yes. So all these are nothing but negative test cases. The way you think, the way the tester thinks now, think about your code. So writing test cases or unit test is also a challenge. Okay, so what I will do now, I'll go to my here customer service test. Now my first test method I'll be writing. Now see, if I go to the code again back, I want to write a test case for this condition, correct? So give the name of the test method accordingly. From where you can come to know, okay, this is what the condition, this is not condition, sorry. This is what the test case I'm testing here. By reading the test method name, I should be able to find it. Okay, so what is a good name I can specify here? For example, as per the test case. Now this is my premium condition, right? Premium customer. So what I will do, I'll give the name of my test method as accordingly. I'll say there this is premium. The good practice is that I should always use okay, so I think there is a convention. Let me show you that what is that convention we follow. I just want to be more precise here because this is what the training we have, right? So we cannot go with, I do have, let me see it. Somewhere I mentioned the, yeah, this is one, correct. Now see, this is generally the convention what we follow. See, we have given some certain rules are there. These are not mandatory rules. This is best to have, good to have. So the project name should be create a test period named under this one. So for each class, create at least one class with the name, class name test, you can see. And then for each method, create at least one test method with the following name. Method name underscore state under test. Now the condition which you're testing and underscore the expected behavior, whether it is pass or fail or exception. So you can see method name is, this is my method name, what I'm testing it, right? Underscore the state under test. What is the state under test? Valid file lowercase, and it returns what? True. So this is how we can follow these conventions. There are many more conventions, but this is the good one what I see. Okay. So let's go with this condition, with this criteria. I'm back here now. Okay. So first I will use the method name, which is nothing but apply discount underscore the condition. What is the condition? I'll say premium 10% discount, right? We cannot write percent discount. Okay, what is expected here? Suppose I say success. This is my right. I can say success also, correct? So apply discount underscore premium 10% discount success. Now I'll be writing the code inside this. I'll say rather here expect, right? Expect success. Okay, that gives a better understanding. Okay, I'll delete this now. Now thing is that if I go back to the code now I want to test for this condition. Now what all the things I want? Yeah, order amount and customer type is required. So in short, yes, I need customer instance and order instance, wherein in this instance I'll set the customer type in this instance, right? I'll set the customer type as premium, right? So in short, what I'm saying is you need to create a test data. See, whenever you create a unit test, okay, to test the code, you need test data. Without test data, you cannot test your code. So how you'll prepare the test code now? I need to create one customer instance, okay, in which the customer type should be premium, correct? Right? And order amount should have some amount in it, right? If it is 0, then 0 into anything will be 0 always, right? Okay. So at least these two things are important. Setting the customer type in the customer instance and setting the order amount in the order. These two things are required, correct? You have to prepare the test data in such a way that this condition should become true. Only then it will calculate the order amount. Yes. So let's go and create the test data. So first, prepare the test data. See, whenever you're writing a unit test, again, I'm going with the best practices of writing a unit test. Okay, giving the right convention, giving the right names to the test method, test class, and the namespace is also a part of best practices for unit test. Similarly, the other one is that you should have a proper structure of your test method. Okay, your test method is not a single line, right? Some test methods are very huge, so you have to organize those, the content of your test method has to be organized, arranged. So we follow one pattern for that also, to arrange, to organize the content of test method. We follow one pattern known as triple A pattern. Triple A. I mean to say triple A pattern. Okay. So triple A means what? The first is known as arrange. The second is known as act. Third is known as assert. So this is known as triple A pattern. So what I should write in the arrange? In the arrange, whatever the arrangement you are doing, right, in order to prepare your test data, right, all those things has to be written under arrange. In the act means take the action. Once you have the test data, you have to take the action. So what is your action here now? The action is to trigger this method, right, to call this method. In order to call this method, you need to create the instance of this class also, correct? So create the instance of the class, right, will go into arrange. This also goes into arrange. Okay, but calling this method, right, will come under act. Will come under act here, correct? And then it will give you the result, right? And this result you will check in the assert whether the result what you got from that method, okay, from that method is the one what you are expecting. Okay, so first let's go to the arrange and prepare the test data. So first I'll prepare the customer, right? What I will say here, okay, here what I have is customer ID. Provide some customer ID, anything, whatever you want. This all test data only, right? Don't have to worry. The customer name, I'm just giving some customer name just to be more, realistic. I will say, okay, some name there. Suppose I will say Ramesh. Then what I have is customer type. Now here I will say customer type dot premium. I have to set it premium because I want to test it for premium customers, right? This is one. I'll go with the another one. What I have is order, new order. Again in this order ID, keep some order ID, anything order ID you want. I'll say product quantity equal to, I say suppose 1, and then say amount, suppose some amount over there, right? What else we want? We have created the instance of customer order. So I need to create instance for this class also, right? If I don't create the instance for this class, I cannot call the method, right? So still I'll say there var customer order service equal to new customer order service. That's it. And I need to pass the instances, right? So customer comma order. We don't have parameter, right? Okay. This will go not here. Okay, sorry. We don't have a constructor with this parameter. Okay. Okay. And then this is enough, right? Now we'll go for act. Act means what? Actually calling the method. So what I will do, I'll call the method customer service, right? Customer order service dot apply discount. And here I'll give the instances customer comma, order. Done. So when I call the method with these values, it will go and process, right? Then what I should test now? How will come to know? Now I need to test whether I got the discount or not, because I am a customer now, a premium customer. So whether I got the discount or not. So to check, I should be using assert. Assert statements are there. These are coming from NUnit and dot. There are many things you can see here. Okay, so I have to choose which is correct. So I will go for R equal. Okay, because I need to check the content, right? Or I can also say here is true. I can also say is true, bracket, then I'll write the condition. I can say that order, right? I need to check the order amount is equal to what? The amount. Now, for example, I know the order amount, the actual amount is what? 360. I need to discount on 360, correct? So what is the final amount which will come? A 10% discount of this 360 minus 36. That will come, right? So that is an amount which I have to write over here. I think that will come as 324, correct? So either I can write the assert in this way, right? Or the other way of doing it is also there. I can write assert in many ways, huh? Right? But the aim is that I need to compare amount and 324. I can also write in this way. Example, I will not say is true. I'm just showing you different ways of writing assert. I can also say R equal amount, comma. This also works. Both are same. Okay, both are same. But you have to write any one of them, not both. But you see this number 324 becomes quite difficult for anyone to understand what this 324 is. Correct? No one understands what is 324. Okay. So to make it more meaningful, what I will do, this is my expected result, right? This is my expected result, correct? So I always write my expected result in this way. No, expected result equal to, okay, I will say 324. I don't have to write any formula here. Don't write formula, please. Don't write formula. This is my test data. I don't calculate. Formula is there in my apply discount. So I'm directly writing 324. You may ask me that why I'm not writing formula. I could write there, but that doesn't make sense. Okay. This is my expected value. I'll say not result. The better way word is expected value. Okay. This is my actual value. Okay. This is my expected value. Now I can compare this with expected. Correct. Now this becomes more meaningful. So always keep a habit of writing expected values. Now save the code. And now if you see here, I can build the whole solution again. You can see the test cases will run after the build is successful. You can see it is searching now. It got searched, right? And now I will run all the test cases. Now I'm running. Yeah, all are passed. Here I can come to know the details of this test method. Got it? Now how to write a negative test case for this? So let me first copy the same thing down so that we can reduce the time. Now here what I will do, I'll change discount expected failure. Okay, I will say failure. And as you as someone said, na, for example, I'll just say there 326. Okay, what will happen in this case? The test case will fail. So we don't want failed test cases. What we should be doing is that you should be writing the test data in such a way that it should fail. Means you're testing the code with a negative scenario. Okay, getting it? So how to fail? How to make this code fail? For example, if this is my code, how to fail my code? null with customer and order. Okay, we have done this null. Apart from null in the business case, I'm saying in the business condition itself. But yeah, null is also correct. Good one. Yeah, this is what testers do. This is what testers they do. Think something where things will not come out. Okay. Yeah, that is good thought that customer type should not be given. Okay, or customer type. It is also basic. Yeah, we can also give the customer type which is not premium. That is also one more negative thing. I think someone has told this. See, we should also check the business code. The business code is completely dependent on the order amount only. So order amount is again based on this discount only. So if we go up to here, then means we should not allow the code to go here. So this condition should make it null. So yeah, so what we can do then, either I should not, see when I say I should not provide customer type because it's an enum, right? Without giving customer type, let's see what happens now. Okay, let's see. Okay, see now, one test case got success, the first one, right? But this got failed, right? Now here, yeah, but the test, sorry. The thing is that if you are changing over here, you're not giving the customer type, the test case is failing, fine. But you should write the assert in such a way that it should pass. Test case should pass, but the test data internally should give the negative result. Getting it what I'm saying? So here, what I should be doing is, I'll say not equal. The right value is 324. If it gets 10% discount, the value will come as 324, but they should not be equal to 324. It means it is negative, right? So after doing the changes, save the code and then directly build from here. If you run the test cases, it will build the things and then it will run. You don't have to build again. Right? Now this is clear, right? This is a negative. This is negative. I'm saying expect failure. I'm expecting a failure. Doesn't mean the test case should fail. No. Again, I can also write one more test case for null. I can also write for exception also. Getting it? So in the code, the exception could be there. Now, what can be the exception here now in this code? Is there an exception will be thrown here in the code, in this particular code? Is there any possibility that the code will throw the exception? So when I give null value for any one of the value, any one of the instance or both the instance, what will happen? Here itself, I will get an exception, right? For this, the value is not there. Fine, he will not say anything. But when you are saying null, this one, it will say null. It will not give null argument. It will give null reference. So this is also we should check. So the moment you say null, it becomes the exception one. And how to write the exception ones and all, how to write unit test for exceptions, that is the coming part. Or you want to write the exception test case here? Okay, people can try writing a unit test for exception. Okay, so you can copy the same thing like this. Okay, I'll say here. Okay, expect exception. So there are different ways of writing the exceptions and all. We have an expected exception is also there. Even in NUnit also there is a way. I will not go with the NUnit or any framework related methodology here. So without using methodology of framework, I want to do it raw. So what change I should do in the code now to make it successful exception? I know that, see, first of all, okay, see, I have to prepare the test data in such a way that it should throw an exception. Getting it? So what I can do, very simple, very simple, right? I don't want all these things. I'll comment out. Instead of this customer, I'll just simply say null. Now in this case, I have to change the assert. Getting it? I need to change the assert. Okay, so first, what I should write in the assert? For example, what you should do is, there are many, okay, just check what different options you have here from here. Is null what? Order? Or else, for example, just to satisfy that, right? Okay, what I can do here, I can say here, okay, just to satisfy. Okay, unexpected value can be, okay, makes sense. Anything will do. I can also give it order also. Okay, fine. I will give this as order. It is both one and the same. Okay, any other thing here? Will it run? Let's see. Okay, I'm saying run all. It's failing. Why it is failing? Let's see the reason. It says that system.null reference exception was thrown. Got it? So if you see here, we got this exception. That's the reason, you know, for example, here, this code has thrown an exception because this is null. He's trying to execute this line, this piece of code. This will throw an exception. Okay. If you're clueless, right, what is happening? So you can also debug the test case. Okay. So I'll show you how to debug now. Put a breakpoint anywhere, wherever you want. Okay. This place and also at this place. Okay. Now debug. Just right click under the methods, the same test method, and say debug test. Okay. Don't do this on the class level. I'm saying on the method level. If you do it on the class level, every method of the class will go under debug. Okay. Underscore debug. Put a breakpoint here also. I'll put a breakpoint. It will take some time to debug. It will load all the symbols and everything. Initially, when you run the first time, right, the very first time for debug, it will take some time to start. I'll put one more breakpoint here also in our actual code, and I'll go back. Now I'll debug here. F10, fine, F10. Now if I say F10 again, you can see it came here, right? And if I try to execute this line, it is throwing exception, right? So it means that we need to write a condition for this. Okay, so basically you should be writing a condition for exception, a test method for exception. Okay, if you stop here, you got to know that where it is failing now. Now you need to fix it. Now if I write try catch, it means that I'm writing a code to even take care of the exceptions. That is nothing but comes under refactoring. So now, even though I write try catch block over here, what will happen? The code will not fail, but my test case will still fail. You want to test it? Okay, I'll write the code over here. I'll just write here. Either I can write try catch, or I can say that if customer is equal to null, do this thing. I can do anything. There are two ways of doing it, right? But okay, let me write try. See, writing unit test is also an art. Okay, that's the reason I'm saying writing the correct unit test makes sense on this. Nothing to say. So what we can do, because it will come when the customer generally what we do in the exceptions, we log the exceptions, right? But we don't have here, and then we move further. Okay, I'll not write any action over here, right? Or I can say better thing is that just to make an understanding. Okay, that is what we do, and then we move further. But even in this case also, still my unit test case will still fail. I mean to say, it will not give me, it is still failing. And if you see the reason, still it is null reference exception. This will also pass the test without doing anything, without writing anything, correct? But our aim is not to pass the test case in this way. See, what we have to verify here is that if the exception comes, that exception, see, we know very well in this particular test data, what kind of exception will come to me. I know very well. Getting it? So I should write that exception over here in the assert. I should write that the exception, what I'm expecting is a null exception, and that I should compare. My expected exception is null, and I should compare the expected exception with this piece of line of code exception. Getting it? Then the unit test case is ethically correct.
Just a quick info, guys. If you wish to learn testing and make a career in it, then we have a good news for you. Intellipaat provides Test Architect Master course in collaboration with IBM and Microsoft. The course link of which is given in the description below. Now, let's continue with the session.
It is not about, making the test case fast. This is fast now. If I run the case, if you see, you will be happy. Okay, test case is running. It is true. But that is not correct. No, this is not correct. Some people, they do, developers, when they're running out of time, they do like this. Getting it? But this test case is not ethically correct. So earlier, actually, when I say now, instead of order amount, if I say order also, it will be passing. For example, here, if I go and just say order, this is also correct, but this is not ethically correct. Getting it? Why? Because order is null and this is null. So even though I write blah 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 here under, still this statement is true, always true. So this is not ethically correct. So what ethically correct is that is what we have to learn now. See, what I should be doing here is, okay, I will be writing try catch here also. Getting it? I should write try catch because this code is throwing an exception. And in the catch, this exception. So what I will do here, the way I have written here earlier, this is my expected exception, correct? And here, what is my expected exception here? Null reference, right? Yes, this is my expected exception. Yes, this is. And here, I don't have to write here because I have different parameters here. For example, if your exception is also having some message in it, in that case, I can pass the message parameter also. Getting it? Or if something else is there, I can do this. But right now, my exception is not giving any messages. So I will keep this. I will say there. Better to say that. Got it? This is my expected exception, correct? And what I should do here. So this is my actual exception, correct? So this exception, and now here I should compare this with this expected exception, right? And both should be equal, correct? Now this is ethically correct. This is R equal, na? If you see R equal, what it says, it verifies that the two objects are equal or not. Even I can compare the int also, string also, because even int, string also, their base is object only, correct? So R equal will work for both, whether it is primitive data types or I can say what you have, the reference types or the non-reference types. Okay, now if I run this thing, okay, why it is failing now? Because we haven't written anything in the catch, na? So that is an issue. So we haven't written it properly. Okay, let's debug and see what is failing now. Yeah, we don't have anything. No? That's why it is. We have to write something over there so that now it will get passed. Did it pass or not? Okay, it finished all three. No? Still it is failing. It is failing again. Going off to this, right? Okay, because of that two try blocks, no? That is going on. Still failing now. Actually, we are not using the correct assert statement. That is the problem. We cannot use. Okay, what will we do? What we have there is first we need to check. There is one assert one expected type something is there. So basically, we need to first check the type of the exception and then the value. Okay, so you got it there. So what you have to check here is the instance type should be of null exception and then the object, so that we know that the instance of the exception is a null reference. Okay, This is what we have to write, but all these are types of assert in it. Okay, so we will get the exception, actual exception. Okay, but actually we will be what we can do. Object type. See, the expected exception should be of type. Okay, we can write here actual also. No issues in that. We could write actual also. Okay, this will also work. Okay, this will also work. But basically, the idea is not about not about just checking here. See, when an exception also has a message in it, correct? So first step is that you should check the exception is of type null reference. First thing, right? Which we are testing here right now on line number 106. The second statement should be there. The message, right, which will come with null reference exception should be the same what expected exception it has. Getting it? That is more important to see. Okay, got it what I'm saying? The first thing is that you should check the type of the exception should be null reference, which we are doing here now. And the second step should be that you should check in this exception what is the message coming up. So is the message same what we are expecting? That is more important. So here we can pass the message and we can check the message in the second instance, second assert. So that's the reason for here, whether I say actual exception or expected exception, here I'm only checking the type of the exception is null reference. It is not argument null exception. It should be null reference. Correct. But this assert method is more important to see. This assert statement, what it will do, it will check whether the instance of this particular object, right, is of null reference or not. And then the next step is that to check the inner messages. Okay, just to verify that the exception thrown is exactly same what we are expecting. So see, we haven't written try catch here, because if I write a try catch is handling the catch over here itself, and it is not giving me the exception. Getting it? So you have to put a try catch here. So just make sure that the code is exactly same what I have written over here. So this is the actually raw way of doing it. I mean to say the very generic way. I'm not restricted. This particular logic, right, will work with any testing framework. But again, nowadays actually testing framework has given expected exception attribute also. But that I won't I won't recommend that way, because that accepted exception I cannot fit in the arrange act assert form. So this is the classic way of handling the exception, testing the exception in the unit test. But still, if you want, you can go with the expected exception here, add the attribute accepted exception, and in that parameter just give the null reference exception. That's it. You don't have to write the assert over here. Assert is not required, and nor even this try catch is required. Just write here line number 96. That's it. And now, because now when we are writing the unit test, right, we came to know that, okay, my code is not able to handle exceptions. Then in this case, what I will do, I'll write the try catch here, and in the catch block, I'll take the correct measures for it, so that the exception is not thrown. And then those measures, what you have taken over here, we could check it in the unit test, so that the exception test scenario will be complete. Are you getting me now? So this way, our code will become more robust, and we'll come to know, okay, what are the missing parts in my code. Now you got why unit test is important. See, after discount, see, the thing is that, see, when we were writing, right, the test case here, okay, for exception especially, right, and we were giving the test data, we came to know that our code is not having a exception handling mechanism. Correct. This is the shortcoming of our code. And you should write a try catch. This is how I will improvise my code. Getting it? Getting it? Yes. So when I do this thing, my code is now able to handle exceptions also. It will not fail. So in this way, my code has become more robust, and it will not fail in the test case scenario. Throw the exception, then see, if you throw the exception, it means that then no need to write try catch, right? Anyhow, the code will throw the exception. See, you will write the throw only when This is your last level of the code, the highest level of the code. Sorry, not highest level. It is no, in the inner level of the code. So for example, your code now, for example, see, in this place, right? I should not throw because this is the inner and the highest at one place only. Getting it? But if suppose my apply discount is calling some another one more method, that inner method is throwing an exception. So there I have written the try catch, and there I can throw. There I can throw. But I should throw in the case after I have logged the exception. So for example, you have three methods, A, B, C. A is calling B, B is calling C. Now C has an exception. Don't write try catch in C. Don't write try catch in B. Only write try catch in A. That will take care of B and C, correct? Yes or no? So try catch will make your code slow. Okay. So whenever you are writing try catch, make sure that you should be writing try catch at the highest level, at the highest level of the code. So we write catch in the inner level only when suppose I want to log exception, or not even log exception, I'll say rather, you want to do some extra activity in the catch block. Okay. And you do that activity over here, and then again you say throw. Why? Because you don't want to stop that. See, don't see, always keep a, writing try catch is quite difficult. If I say it's very difficult. If you think logically, try catch is not as simple as you think. No. Basically, what we do generally, in the inner level, we write try catch and we take the action, and then we forgot to throw that exception to the outer layer. If you are doing so, what will happen? You have suppressed, the inner level has suppressed that exception, and this is not recommended. Got it? If you have some additional activity you want to do in the inner level, okay, you do that activity. In that case, you write try catch at the inner level, and then then you can do that extra activity and throw it. Don't suppress, don't forget to throw, and say only throw. Don't say throw ex also. Okay, that will not give you the inner exception. We want the complete stack trace to be thrown to the upper level. Okay, correct? See, all these are coding best practices. You'll get more insight knowledge about try catch, because each developer should know how to write try catch efficiently. Exactly. See, in the test case, that's the reason in the test case, I'm writing my try catch so that I should get the exception what is been thrown by the actual code. That's the reason I've written try catch here in my test cases, because I know that very well. Line number 96, this line will throw an exception, and what kind of exception it throws, that also I know. And to handle, to catch that exception, I'm writing this try catch block. And what I'm doing then, I'm assigning the actual exception with the exception what I got, and I know what is my expected exception over here, correct? And then I compare. First of all, I check that the exception which has been thrown by this code, right? Is it null reference exception in this first assert? Okay, if it is true, then in the second assert, what I should check is the inner message, if it has. Because I also know that in the inner message, some message is there. For example, in this case, right, object is not set to the reference, right? That message is there. That message I can check here. But again, this is also restricted to the null reference. So that's the reason I'm not comparing it. Getting it? But in the real-time scenarios, when you write the code for the actual code, you always write a message inside an exception. Always. Okay. That too with the message code, message IDs and all. If I talk about very corporate level and very enterprise level, every message what I write in exceptions or wherever, we create those message IDs for each exception, and we also publish that message ID and the respective messages to the client also. Okay, getting it what I'm saying? So a lot of things are there. Writing a code, just a code like a textbook, will not suffice in the corporate level. So that's why there is a big difference between a training and actual coding. So I'm giving you the actual code which we write in the product. This is the production level code. What I'm trying to write here is a production level code. So this is one of the scenario what I was about to show you, but in the later stage. But okay, it came in the flow, so we have written it. Okay. Now, if I talk about attributes, what is attribute? Okay, we know that attributes are nothing but which will help us to declare a class as a test class, method as a test method, and all those things. So there are many such attributes, which will help you in identifying the test for the test runner also. Okay, you can see there it will recognizes and load tests, help the framework in identifying the tests that need to be invoked. Okay, NUnit provides an assembly that contains these special attributes. Okay, so and all these attributes, we know that these are all coming from the NUnit assembly. Okay, the DLL, right? The NUnit dot framework DLL is there, right? That DLL will have all these special attributes. Okay, and that's the reason it is said that you should have a reference to this network NUnit dot framework assembly, which we had done right in the code. Now these are some of the examples of attributes. We have seen test fixture. We know that test fixture means it denotes that this is your test class. Okay. Then again, we also have test. We know that to declare a method as a test. Okay. We also have ignore attribute. Assume that suppose you have a class. Okay. Now in our class, right? Suppose there are test methods, 3 test methods or 4 test methods are there. Okay. And I don't want to run one of the test case. Right? Out of 4 test cases, suppose I want to ignore one of them. Okay. So what it means, ignore means it will not run. It will not run the test case. Okay. So to ignore a test case, or in order to not to run a test method, we should put the ignore attribute. So I can put the ignore attribute on top of a test method like this, right? Or on top of a class also. First of all, if you don't put any attribute, okay, the method will be taken as a method. Okay, it will not run. It will not run as a test case. It will not run as a test method, but it will not even consider this as a test method. It is just a null method. And yes, there are some scenarios where in my class, right, in my test class, I need some private methods also, right? For example, especially we require such methods when I want to create a test data, right? So preparing test data, I can prepare this test data. For example, the same test data, if you see, okay, this is a good one. So let me show you what I'm seeing here. Now, if you see in this method, right? In this method and this method, right? The test data is mostly same, correct? The test data is mostly same. There is no customer type here, and their customer type is there, right? So why don't we then create a method, okay, which will get me the instance of customer, and we can keep the customer type as a parameter. If I want, I can pass it. If I don't want, I will not pass it. This way, I can reduce the code which is common between multiple test methods. And in this case, I need to create a private method, right? I can also create public also, no problem. But public is something, no one will create the instance of your test method and will call the method, right? Even though you write public, but it is not too good to have public there to be in sync with the C# concept or OOPS concept, we'll create those as private methods. And in this private methods, we'll not add the test attribute. But what is the difference between ignore? Ignore is that the test method is there, but it will not run. Okay. It means that the method is considered as a test method, but because you added it as an ignore, it will ignore. It will not run it. But by default, but internally, the test runner knows that, oh, this is a test method, but I don't want to run it. I should not run it. That is the message goes to the test runner. So now there are few more attributes are also there. So let me, first of all, should I start this right now? Okay, before I introduce the new attributes, there were some certain more configurations on existing attributes like test fixture and test. Okay, let's go and finish those things, and then we can take these new things as setup, tear down, and all these things. Okay. Okay, so we know that the test fixture is there, right? We know test fixture, right? So in this test fixture, we can also pass parameters to the test fixture. Okay. We can also write generic test fixture, means I can write a test fixture, right? A generic test fixture. So what it means is that I can use the same class, test class, in multiple ones. For example, where I have a hierarchical structure, right? Yeah, I was talking about the parameters, adding parameters to the test fixture. And, even I can do an inheritance. For example, I can create a base test class, a child test class, and I can inherit. Okay. Similarly, I can also create a generic test class. Generic means, the generic class is what we have in C#, right? Similarly, I can also create some generic test fixtures. So I will discuss first on this, and then we'll go forward. Let me go to the. Okay, we know that the test fixture, if we see in the code here, this particular attribute I cannot keep on the method level. Okay, means I mean to say, like, I cannot do so. You can see an error is coming. Okay, this is some of the limitations what test fixture has. Okay, now for example, I can. Okay, so I can pass parameters to this test fixture. Okay, and these parameters are nothing but, these will be nothing but how I can be doing this thing. These are nothing but the constructors, right? For example, if I pass some parameter here, like this, here, you can see there are two variations, right? Two overload methods are there, right? So I can pass parameters to it. So the parameter will be, for example, okay, what I will do, I'll write the parameter like this. Okay, let me add the parameter dot. I can pass a parameter like this, and then I can use this parameter in my constructor of this test class, something like this. First, for example, I will declare a private, okay, and I will say there customer type, and I can initialize this class over there, and I will say there customer. And here, what I can do, I can, yeah. Now the thing is that I have the same name here, right? Customer type and customer type. What this means, how I should be using this and this together. So to do that, what I will do, I'll say here this dot customer type equal to customer type. Okay, so this is how I can provide the values to this class for the customer type in this way. So this value will go here, and from here it will be initialized to this one, and I can use this customer type further down wherever I want to use. So when this test class will run, right? When the test class will run in the test runner, at that time, this value will be passed to the customer type. At that time, okay? You may ask me that actually when this value will be passed. Okay, so I'll say that who is calling, who is invoking the test class? Test runner, right? The test runner is invoking the class. At that time, the test runner will pass the value basic to the customer type, and customer type from the constructor. Okay, its class level customer type member will get initialized. Similarly, I can also add more things to it. For example, I can pass not only just, now this is something, one parameter. If I want to provide many parameters, not just one value, multiple values, I can do that. Because if you see,
Just a quick info, guys. If you wish to learn testing and make a career in it, then we have a good news for you. Intellipaat provides Test Architect Master course in collaboration with IBM and Microsoft. The course link of which is given in the description below. Now, let's continue with the session.
the second variation, it's an params array. Okay, params array means I can write any number of parameters separated by comma. So for example, with basics, right? Okay, what I will do, I'll not do a change here. I can write multiple test fixtures, okay, attributes to the same class. For example, this time I'll say this is as premium, comma, and I'll say some value, suppose, okay, okay, and for example, I can say some value like 150, okay, 150.00. Now, in order to use this second test fixture, what I have to do, I have to create one more constructor. Only then only then both the test fixtures will work, otherwise not. Now, the second constructor will have two parameters. So for example, I can say this is the double value, double, and I can say minimum amount, okay, and then this minimum amount, right, will go to the minimum one. So for example, I have to again declare a class level. I'm intentionally giving a different name so that we should not take it as a rule that both the variable name should be same. This name and this name should be same. No, not required. And here, what I will be doing the same thing. This dot. Now I don't have to write this because I can write amount directly, and I will say minimum. Now I have two constructors and two test fixtures. So make sure that whenever you're adding the parameters, whenever you're adding multiple test fixtures, every test fixture should have its corresponding constructor. Okay, so forget about whether the test cases are running or not. Those things are not important right now. But you can see that now the custom order service test is running two times, right? One with the basic parameter, other one is this parameter. Getting it what I'm saying? And each class will have its own, the same number of test methods. Here also, it is having same number of test methods. See, even in some cases, right, you want to run the same test method with different values, but that happens on the test method level, correct? But this is happening on the class level. So I want to run the same test method with different values, with different test data values. Okay. Now I'll go to the second variation. Okay, so what I'll show you now is that now you have a scenario, right? In your real-time applications, right? In your actual code, right? You have an hierarchy. Okay. You have a base class and a child class and again a child class, or one base class has multiple child classes. Okay. So this is an inheritance, right? And what you want to check is that you want to validate the logic of the base class. Okay. And once you have validated the logic of the base class, okay, you want the same thing is being followed by the child class. Okay, so once you have a logic at the base class, the same logic has to be whether the child classes are following the same base class logic or not. If you want to validate this scenario, right? In this case, you will create a test picture at the you will write a test picture for the base class, and you will also write a test picture for the child class. So let me quickly give an example here. I'll write the example. Okay, so I'll add the class as a class, and then after that I'll convert it. Okay. So I'll make this as my employee class. Make sure that first of all I'll make it as public. If I don't make it public, test runner cannot identify this class, cannot find this class. Now here I'll be, before I do this one, right, I'll create this class under code, and then I'll come down to writing a unit test for it. And since this is my base class, of course I need to add, I need to call an abstract class, and here I will add some member in it, and I will also add public bool. I'll just add some, I'm writing some logic here. I'll check whether the name contains a dollar or not. If it contains dollar in it, I'll say return true, or else I'll say return false. And now here I will create some child classes here. And here I will be having one more. Okay, this is structure what I have now. If you want, you can write the code and also do it along with me. Now once this has been done, what we should be doing here now. Now I'll go to my test picture. This is very simple code. I'm not doing anything great over here. I have a simple logic in my base class. Okay, I have a very simple logic in my base class. It is nothing but it will check whether my name has a dollar in it or not. Based on this, it will return the value, true or false. Okay, and the same base class has been derived under manager and delivery manager. Okay, now what I will do here, if I want to implement the same thing here, I'll save the code. Now how to write a test class for it, right? So first of all, I'll be adding a test. Okay, all these attributes will not come unless I will be writing using NUnit dot framework. Okay, and here, since I'm writing a test for employees, so I will say employees test. And here what I will do, inside this class now, I'll create some methods and all. Now, first thing is that I'll add one virtual method which will give me the employee when I say create employee. Okay, when I say create employee, and what it will return new employee. Means it will return the instance of the employee. So cannot create an instance that is very true. So what I can do here, let's say create employees, employee only, right? And I should pass the instance. Okay, now this is a method I have, and then I'll write the unit test case, right? For, okay, now I need to check the business logic what I have in my base class, correct? So for that, I will create one test class. So okay, I'll not write too many code here because I need to write so many things here. So what I will do, okay, I'll write small simple things here. My method name, what is my method name over here is contains illegal character. So I will write some illegal characters are there, contain, and it says that. Now what I will do, I'll be writing, okay, I'll write some code over there, okay, which will pass the test case. Okay, so just to be in sync, so that you should not lose the path. Assert is true, and I'll say that suppose true. Okay, this will at least pass my test case. Fine. Okay, so this is what I have for the employee class. Okay, now when I will write the test case for the child classes, for example, here if you go now for the manager and for the delivery manager, you need to write test cases for this also, correct? Right? Because even delivery manager and manager will also have this method in it because it got derived, correct? Now, because I have written a test class for the base class, okay, I don't have to write the test methods or the test cases, okay, for my business class, for my business method in my derived classes. Okay, so what I mean is, I'll show you. When I am writing now, okay, now this is for what? I am doing it for class manager tests. Okay, right? When I'm doing this thing, what I should do, I should derive this manager test class from the base class, that is employee test. Okay, and because I have derived it, okay, the only part what I will override here is this. That's it. Okay, and here I will not write this part again here. Is it required? No. Now the same thing I can also do it for the delivery managers. Again, I don't have to write separate test cases for this method, correct? Because I am maintaining the hierarchy. I am maintaining the inheritance. So this method, why I don't have to write? Because this method is already available over here, correct? When the test runner will make the instance of manager test, because manager test got inherited from employee test, this public method will also come here. And that's the reason I don't have to, again, the business logic is same, correct? So if the business logic is same, then the logic comes that, then we think logically that why I should write again the same set of test cases for derived classes. So how can I skip it? I can skip in this way. That is the part. Actually, basically, I should not write this also here, but we can write, not an issue. I will not write because what I need here, is to get the instance of employee. For the employee, instance of employee should come. For the manager instance should come. For the delivery manager instance should come. And here, I will not say virtual, I will say override. So this is an inheritance scenario. Okay, the last thing is about the test fixture is that I can also create generic test fixtures. So we have seen that in the test fixture, I can pass the parameters. Okay, I can also do the inheritance of test fixture. Similarly, I can also restrict, right? For example, I can say that a special type of values only should be should be given to my test class. Okay, so in the other way, I'm saying that my test class should work, okay, with a specific type of values only, not with all values. If I want to do that restriction, right, my test class will work with some specific type of data only, not with all. So then this goes as generic test fixtures. Okay, how to do this thing? I'll show you. So what I will do, I'll put, so where is my here, right? What I will do, I will go to rather my, yeah, here. I can specify that, this values, and here I can say that type, okay, and we'll say I am giving a new type, a type array means I'm creating an value array here. Okay, so basically I'm saying that value, this one type array. I can do that, and what I will do, because I need here two things, right? So what different values I want to use over here, and here I'll first of all give. I know that I need customer type, right? I'll say their customer. Second thing is type of double, correct? So see, when I'm passing the values here, right, this value and this value, I'm restricting the type for them. I am saying that the value type for this parameter should be double. It should not be decimal. It should not be currency. It should not be float. It should be double and double. Okay. Similarly here, when I'm passing this value should be of customer type only. No other value should come here. Okay. So I'm giving restrictions to my type. So for that purpose, I have written this array. Now, what I'll be doing here, now so this is generic type, right? So yes, I need to do like this, right? And I can say that this will become now what? T1, correct? This will become T2, correct? And here also I need to say here the same thing in one. Here also I will say T1. So this is something about, I am restricting the type of the values. So by mistake, suppose someone is giving not the double, but a currency value, it will not accept. So in this way, this is a generic one. So this class will work with only with two types. One is the enum type, second one is a double value. No other values are allowed. Yeah, clear? Okay, so one part is that we know about this test, right? What this test will do, here there are two ways of doing it. Identifying a test method. So when you say test attribute, it will become a test method. You can also say test case. For example, I have used this thing here. I have used here test case. I can use test or test case. Similarly, I can also give only test. If suppose I want to pass parameters to this test method through the test attribute, I cannot do that. You can see, I cannot do that. And means I mean to say the parameters are nothing but the author name and description and all those things. I can pass over here, but specifically the arguments, whenever you want to pass arguments to a test method through the attribute, what we do it through test case. Okay, means the way we had done it over here, this test case. And this test case has, either I can pass the values or I can pass the values, multiple values, okay, or I can also pass multiple object values, okay. So these are variations of test case. So basically, whenever you want to pass parameters to your test method, okay, so don't use test attribute, I'll say rather use test case. Okay, I'll show you how to pass parameters to the test. How to pass parameters to a test case. For example, it's very simple. For example, here you want to, the better thing is I'll show you it over here. Now, what is expected over here? Premium, right? Customer type premium. What I will do, I'll pass here. So when I provide values, this thing, what will happen? This particular test method will run for all these values. First, it will run using the premium, then basic, and then special customer. So what will happen in this case? I have to use this value, right? I have to use this value. Okay, that one part I missed out, right? Yeah. Here, what will happen? Customer type, and this will become my customer type. Okay, I can use this customer type here. I'll not put anything, yeah? Right? So this is what we'll do. And another part, what I can do here, because this value also should change, right? Correct? Otherwise, the unit test will not pass. Getting it? So whenever you write such scenarios, make sure that whenever you're passing multiple values, it should work. So 324 is 10% discount, correct? What we have to do over here, how you'll make pass for all three values? Yes, this will become, and here I need to take one more. This is int. No, this is not int. This is double, right? Decimal, and I see this amount. Okay, so in this way now, this becomes a complete test case which will run for all the three values, and it is okay. So you can see here this premium is passing, right? And you can see under premium also it is running for 3 times. Getting it? See, for premium 10% discount, right? It is running for 3 times. See, for example, we know that, right, in real-time scenarios, right, in our real-time application development, multiple developers, right, code for the same project, right? It means that if the project is big, right, so 3 or 4 developers or 5 developers are working on the same piece of project, and will have some different set of test cases written by different developers. How we will come to know which test case is written by whom, right? So for that, we also have an attribute author, which is seen in the test case. In the test case, just to have a note, I can say here, whenever I will be writing the test case, I'll put my name as Shiv, and this will give me, okay, right. This has been done by me. And we need to add one more. Okay, I'll put this. Okay, basically why it is not working there, why it was not working here, but I think this is also not required nowadays. From the, if your code is integrated with your GitHub, right, or any source repositories, from there the author name comes, not only for the test cases, for every piece of code, right, which a developer is writing. Okay, for that his name will appear. The way we are seeing zero references and all. Similarly, we can also see the author name there. But if it is integrated some source repository, okay, but this is from the test case level. Similarly, suppose if you want to change the name of the test case, right, we are not happy with the test case name what you have given over here, okay, those name also you can provide here by saying is name, and you can provide the name in double quotes, whatever name you want. So then the test runner will display this name, okay, not this one. This is about your test name. Okay.
Just a quick info, guys. If you wish to learn testing and make a career in it, then we have a good news for you. Intellipaat provides Test Architect Master course in collaboration with IBM and Microsoft. The course link of which is given in the description below.